Welcome back to a new video. I always wonder how a jet engine works. So now we are going to figure out how it works. But what is a jet engine? It's a type of a reaction engine discharging a fast-moving jet that generates thrust by jet propulsion. In this case, air. Yep, it has the same principle as a rocket engine. What kind of fuel do they use? The kerosene is a flammable liquid mixture that are produced in the distillation of crude oil. It can be used in aviation as an oil in central heating systems and can be used as a cleaning agent. What oil do they use? They use an oil which is resistant to high temperatures, allowing it to maintain a better viscosity.
I designed this turbine in SolidWorks. It has 12 pieces for educational and demonstration purposes. I did a simulation of airflow at ambient pressure and with the compressor rotating at 50 radians per second. Now we are going to proceed to print it in 3D. I will explain the function of all these pieces. The shaft. This is responsible for delivering all the force generated by the turbine to the compressor. The compressor. This piece is responsible for delivering the air while it is compressed, increasing its pressure to the angle of the vanes can be set between 10 to 30 degrees of angle, and this can affect the efficiency of the engine. The bearing. This part must be able to withstand high temperatures because its function is to eliminate friction, supporting the shaft and transmitting the movement force. The diffuser redirects compressed air to the combustion chamber. These holes are made for the oil and kerosene pipe. The shaft housing protects the shaft and bearings from hot kerosene gases and distributes the oil through these holes to the bearings to keep them lubricated. If you wish to build your own real jet engine, take in mind the necessary screws to keep the engine joined. That is why the diffuser has the holes along with the holes in the shaft chamber. The intake nozzle. This part is responsible for maintaining the air. Often auto control circuits can be mounted here. Look, that has holes for the oil and kerosene pipes. The combustion chamber. This is where the magic happens because the kerosene is injected through the pipe. The drops are being pulverized into small particles. Then they hit the wall and is redirected towards the turbine. Why this design? Because the air that arrives at a certain pressure is compressed, accelerating the air and generating a pressurized zone passing through the holes, guiding the oxygen and the kerosene mixture towards the stator. The turbine stator. This piece redirects the mixture in a specific direction and the turbine starts to rotate. Turbine. With the mixture, the turbine generates thrust while moves the compressor, making the engine self-sustaining. You can control the velocity depending the amount of fuel that gets injected. The exhaust nozzle. You may notice that it has a similar design of a rocket engine. This piece takes the remaining energy to create an extra thrust. I already finished to explain the main pieces of a jet engine. However, the design of a jet engine can be different with some pieces, but at the end, they have the same principle. You know a little bit more of how to design your own jet engine. In the description below, I left you a link with a RAR file where you are going to find three folders. The first contains the design part in SolidWorks, include the assembly file. The second folder contains the .stl files, so you can put them into a 3D printing software. And in the third folder, you got the G-codes to get your pieces printed with a 3D printer. The pieces has a tolerance of plus minus 0.5 millimeters. Due to the expansion of the PLA plastic because of the head, the pieces do not feel well. I fixed that problem by sanding some parts of the pieces. If you want to design your parts on lathe or in a CNC, you must know how to assemble the pieces, so let's proceed. Buy two 21mm bearings, place it here, put the shaft inside the shaft housing, leave the remaining bearing until the end. Now proceed to connect the diffuser with the shaft. You can go ahead with the compressor or with the combustion chamber. The combustion chamber is conformed with three pieces: the base, the internal wall, and the external wall, which has the cylinders. Join it here and here, and it's ready. Now, put the turbine inserter right at. Once, put the engine housing in place. Now, the turbine inserter, and finally, the exhaust nozzle. That's how it will look like. We have the inlet, the combustion chamber area, and the outlet. Remember that this is a 3D printed model. It is not functional. However, the real ones can have clamps to perform a better stiffness. This is how the microjet engine looks like when it's working.
Thank you very much for watching this video. If you enjoyed, don't forget to like, comment below, and share it with your friends. I specifically recommend to you to subscribe to this channel so you won't miss further videos which I develop a real jet engine and teach you how to model a rocket nozzle programmed in Python. See you!